Okay. Thanks. That works. Hello. My apology for the short delay. Projecting slides is still an unsolved problem, even in 2020. When I want to talk about how to instrument code in 2020, the title is actually not very well chosen because it's not a how-to. There's literally how-to in the title, but this is like more high-level talk. Let's take a step back and check out where we are and where we'll go in 2020. The how-to happened yesterday. Bartek and Kemal. Bartek is here. You can still ask him about this awesome talk. So they gave a pretty good how-to instrument code, even in 2020. I want to talk about the general concept, and it is apparently fashionable to refer to pieces that Peter Bergen wrote. I've seen that yesterday in a talk. And Peter arguably has the talent to write blog posts and tweets and stuff for people later refer to in intended or unintended ways. So this is something he wrote in 2016 based on a QCon talk he gave, and it's a sequel to a blog post of 2014 based on a GopherCon talk he gave, and that was the very first GopherCon ever. So this is living Go history, and I'm referring to this one section, logging and instrumentation. And back then, 2016, and now and before that, we all kind of took logging for granted. We are from different generations of programmers, but each of us, once we start programming, at some point we write a log line to the screen or to a log file. That's kind of natural. But what was not natural in 2016 is you should be instrumenting every significant component of your code base. If Peter writes that, he writes that because it's not done by everybody, which is understandable because instrumenting code was something that many people didn't really do up to perhaps 2012 when stdsd came out and suddenly people got asked to put little lines into the code to emit some UDP package that gets sent to the stdsd server to count metrics and then display it with graphite or something. This is 4 years before the blog post, so 2016, it was still something that had to be called out, and now we are 4 years later. However, people, of course, instrumented code before that. It was just not very widely applied. It was more a niche thing, or it was done by large companies. Anecdotal evidence. I have a history of working for Google. I started in 2006, and when I arrived there in the enchanted castle, instrumenting code was already what everybody did. It was second nature. So, 2012 was also the year where Prometheus got started. Most people think Prometheus got started 2015 when the big announcement happened, but in fact it was developed as an open source project from the beginning, and I was part of it since 2013, so fairly early in. And Prometheus also kind of had this problem that it was a white box monitoring system, or it still is, and it asked people to instrument their code, and back then it was kind of a shock for many. So there's another paragraph here. Instrumentation. Peter says you should instrument, and then if you have any choice in the matter, Prometheus probably the instrumentation system you should be using. Great honor, of course. What I like even more is that he says Prometheus as the whole bigger idea, the ecosystem, and not just the Prometheus server that collects the metrics. And arguably, this is how the legend goes. Prometheus was invented by thinking about instrumentation. It started by, let's write an instrumentation library, let's emit metrics for white box monitoring, and then we have to collect that. And only then the idea for the Prometheus server came up. But instrumentation was the beginning of all of that. Instrumentation libraries have to exist for many languages, but since the Prometheus developer were doing this in Go, which was fairly early in the Go history back then, they also created the first instrumentation library in Go. This one, it's now fairly popular. I started to maintain this in 2014, and we had major rewrites. But now it's this is GoDoc, you know that? And if you look at popular packages, it's down here, number 13 or something. if you go to go.dev, this new module repository, there's also, if you go to explore, there's popular packages, and this is only the top 10, so it's not there. But if you look at the module itself and click on imported by, you see 11,613 importers. That's a lot. Like the most popular packages have like 20,000 importers. So it's really like, let's say, one of the top 20 or 25. To hammer it, JFrog, they also have a Go modules repository, and they just recently picked, according to some metrics, 25 top modules. And if this is the real order, it's like 1, 2, 3, 4, 5, 6, number 9. I don't know if this is in any order. It's definitely a popular module, package, library, whatever. And that also means you cannot just change things at will, because you will break 11,613 people. So at the moment, if anybody wants a feature that requires a breaking change, I just pile this up in a V2 milestone, a legendary. Sometimes I even work on that. But yeah, if with such a widely used package, you have to pile up breaking changes and do them in one big bang, or have some exponential branch for that. So it's kind of interesting problem. But this is not the topic of this talk. I hope my GopherCon EU talk gets accepted, because I will talk about this problem there. And it will also be in Berlin in a couple of months, so you can go there. OK, thinking about it. Prometheus instrumentation library started in 2013, fairly old, has to be stable now. But it's kind of an aging library. Some parts have aged well, other parts haven't aged that well. And we want to talk about instrumenting Go code in 2020. So take a step back. Let's first think what instrumentation actually means. And if you want to know what something actually means, you go to Wikipedia, right? I mean, it could be the greatest piece of something because somebody just changed it, or people have a flame war what actually the truth about something is. So enjoy it responsibly. But I find this always very interesting. And if you read this whole thing, it really reads like an old textbook from the 70s or something. And I think the reason is that instrumentation as a technical term in computer programming is actually a very old term. And most intriguingly, the example they use, for example, instructions may output logging information to appear on the screen, and logging is also here. So logging is actually instrumentation. So Peter wrote logging and instrumentation. He actually should have written instrumentation, right? Because it's not just metrics. And if you look at it, the word metrics is nowhere on this page. I think what gets close is performance counters. That's kind of what we mean by metrics, more or less. So instrumentation is a really broad term, and metrics is really just a very specific part of it. Has become more important, arguably. There's also debugging. I would assume this, I mean, debugging is also a very broad term. This means set a breakpoint and then step through the binary style debugging. Which in some languages needs binary instrumentation. There's also tracing and profiling. And I mean, this is broadly simplified. I just try to create 4 categories here. Debugging, traditional set a breakpoint, step through the binary. Profiling and tracing, I just put in one pocket, which is hugely wrong, of course, but just for simplification, logging and metrics. So now when Go came out, we had this keynote yesterday by Frank, and he nicely described how some people were disappointed. Like, this is the new hot language from this hottest internet company in the universe, and they create this like super simplified C-style imperative, whatever. So some people are really disappointed, and a lot of people got disappointed. It doesn't even have a step-by-step debugger. How am I supposed to develop in this language? Interestingly, there were another group of programmers, probably a minority, who said, this is so awesome. This is a very new language. It has all the tooling that I always wanted. So why are some programmers excited and some others are bored? I would say, a bit like cheesy, that the programmers who are excited, they were the modern cloud-native programmers, because they have a different view on tooling. And Google has a different view on tooling. Google baked into Go what they did in their practical, like how they put code into production. And the thing they didn't build in, debugging, this is something that is, in my opinion, almost useless in a cloud-native, distributed, concurrent world. Because if a program is concurrent or even distributed and you just stop the execution of a single thread or Go routine and then step through it and all the other stuff is just doing their thing. So I used, since 2006, that's like 15 years ago almost, I used a step-by-step debugger twice. And I really had to debug complex problems, just as anecdotal evidence. On the other hand, profiling tracing, which in some languages is like, I mean, back then you had to like buy specific compilers that would create instrumented binary code and stuff like that to do profiling. It was really hard. It's built in. It's not only those packages I put here as a symbol. It's baked into the language. Some profiling needs instrumented binaries, also like race detection, right? You have to compile it with a flag, but CPU profiling, heap profiling, it works out of the box. You don't even have to change your binary. Logging has a very simple log package, Go philosophy. Keep it simple, but we all agree that we should do it in this one simple way. And then XVAR is perhaps something you haven't looked at. This is expose metrics via an HTTP endpoint, like just a text string and a number. It's very simple, but this is how Google is doing this. This is white box instrumentation for metrics, essentially. So all built in, pretty great. Google production knowledge baked into the language, cool. Still, modern needs, like if we really do something serious, we might want a tiny bit more. And now I fill the rest of the table. So debugging is still almost useless. However, if you really want to, of course, we have step-by-step debuggers in Go. So if you want to do it the traditional way, go for it. I don't, or twice in 15 years. So now this is a huge leap here. I kind of say profiling and tracing is almost perfect in Go, but in the distributed cloud-native world, you need to do this in a distributed way if it gets complicated. And I mean, yeah, it's a bit like to force it all into this shape, so distributed tracing. And now we don't have the one module or package we use, so I put one that is fairly popular, or at least widely used. Open tracing, Go, we had talks about it here as an example. For logging, what Peter also writes in his 2016 article, and I think we all agreed on, we want structured logging, which is, it's just a tiny step. This is not a big step. This is the big step. This is the tiny step. It's essentially still the same. We just want some key value structure in our logs to process it better. And Peter, I mean, he says there are many modules, but he refers to his own GoKit log package, GoKit log. I use this as an example. And XVAR 2, Prometheus client Golang, as an example that Peter uses as well. I call this labeled metrics. You could also say structured metrics, non-hierarchical data model. And this is, again, it's a tiny step. It makes a huge difference, but it's just a tiny step. And it's also not super surprising. You might know that Prometheus got heavily inspired by how Google does monitoring. XVAR got inspired by how Google exposes metrics. So it's kind of all connected. OK. So, but if you look at those three things and you squint a bit, tracing, logging, metrics, you have heard about it, right? The three pillars of O. So I'm not pronouncing the O word here because there was so much heated debate that I think by now it's completely useless as a technical term. Everybody understands something different. People use it to fight over words or not, or I don't know. I just don't find it's helpful. I mean, it's written on my T-shirt because I work for Grafana now, but I don't have to use it, right? We also never used it back in the days at Google. This word, I mean, it's from control theory, but it didn't exist. OK, also the three pillars were abused in friendly and unfriendly ways. Like some people liked it too much and overdid it, and some people just hated it, perhaps because others overdid it. But anyway, there's something in this, right? You have those three things. Peter also blogged about it. He arguably invented the term of the three pillars, the metaphor. But 2020 instrument code, this is all there. It's actually even similar. You can say logging some event is kind of the atom, the primordial particle or something. Everything else derives from that. If you attach span IDs, trace IDs to logs and collect them all, then you have already implemented some tracing system, distributed tracing system. If you start to count logged events along certain dimensions, number of 500 served, and you sample their latency in a histogram or something, that's metrics, right? So it's all kind of the same. It's just a different representation and different aggregation and tagging and whatever. So why do we have 3 different packages here? And we don't even agree on the package we use for each. In 2020, this should be easier. Now, I say 2020, but I have to give credit to Ditya, who also is here at the conference again. He was at this conference last year, and he gave a talk that now we record everything, thankfully, but last year wasn't recorded. So you can just look at the speaker deck. So he talked about building resilient services in Go. And surprise, you need to instrument your code to do this and collect all the metrics and logs and traces. And he also said this should be easier, and he works at Stripe, and they have a pipeline called Veneur that is very focused on doing this all in some unified way. They have a sensor, SSF, sensor sensibility format. So they have an idea of doing this in some unified way. And he literally asked this question, why is this so complicated? So this is from his talk. Tracing is kind of complicated to instrument. Logging is just one line. Metrics is essentially one line. But still, you just want to serve an HTTP request, and you do like those 3 different things. And it would be really nice to have a kind of combined view, some consistency. We are Gophers. We like consistency and one way of doing it. But we are kind of not there yet. In 2020. So let's recap. Why is this so hard? So that's our premise. Unified instrumentation for metrics, logging, and distributed tracing. It's all instrumentation, right? OK, not more, not less. It's hard enough already. So this is the obligatory XKCD reference. It's so obligatory that I was yesterday in Johannes' talk about distributed traces. So if we want to create one standard for all of that, the obvious problem is we might just create another way of doing it and have gained nothing. So why is unification useful? We are happy Gophers. We program in a language that mandates the formatting by GoFind, right? So we have to believe in unification being useful. What I like in Go so much is so simplistic, but also so opinionated that you jump into a completely different code base, to an open source project, to something another team in your company did, and there are 0 surprises. That's why it's great. There's also a gain in like libraries. If you write a library, and since we know from Peter, everybody should instrument every aspect of their code, then you want the library to do it in the same way. It would be really counterproductive if the one thing is instrumented for Prometheus and the other one is only for StuxD, and how do I combine all of this? So yeah, there's definitely value in this. We probably agree on that. So, but why or how can we avoid this pitfall? And I think it's a very important insight. You cannot hope for the best solution to becoming the standard we all converge on. For one, it's a matter of taste. We all have different opinions. What's the best? And the other thing is that objectively, depending on our context, other solutions will be the best for our situation. So we have to aim for a solution that is good enough in most of the contexts, and then we can hope for people converging on it. It's kind of, yeah, we have to tone down our expectations. OK, another aspect is if you want this unified library, it should be there for all the languages. Now, this is something Gophers will not understand, because why should you need another language but Go, right? OK, nobody is like, perhaps, I mean, I think, and I think this also resonates with the keynote yesterday, Go is not Scala. Go is not the language that does all paradigms and tries to solve all the problems. And I think this is a great strength of Go. Go is very kind of clear explicitly about use Go for the stuff it's good for, but it's not for everybody and for everything. And it's kind of focused, simple, and that makes it powerful. Like it's kind of Zen of Go. So we as Gophers, we should be really open to doing things in other languages as well. Also, Go is not the popular language. I took this from the current PyPL or PYPL ranking. They use Google Trends to tell you what languages are popular. You could argue that's not the right way, but anyway, Python, Java, JavaScript, C#, PHP, C, C++. These are the 6 most popular languages. I kind of intuitively, I think they are right. Go is number 15 on that list, which is awesome for a language that is, 10 years is, all those languages are older, right? Now you could say cloud native is a bit special, and I would argue PHP cloud native programs are probably less popular, and you might put Ruby in there or something, so you could modify this a bit. But definitely, those languages are important. So why should you be interested? For one, you might find yourself in your career in a situation where you have to program something in one of these languages, and then you don't want to rethink all your instrumentation. So it's nice if semantics, idioms are similar. On the other hand, this unified instrumentation library should honor the idioms of the language. And in the Prometheus universe, we tried really hard to make all those instrumentation libraries we have for all those languages kind of work the same. But it doesn't always work because you want still be a good Go library and a good Python library, so you have to find a trade-off. There's another aspect of this. You also don't want your telemetry to change radically if you, for example, write a prototype of a microservice in Python, because you can hack nicely in Python. And then you realize that works. We want 100 million users for this microservice, and Python is way too slow. So you write it in perhaps Java, or even better in Go. And then you don't want the telemetry changing completely. You don't want to change how the tracing works and how the metrics are collected. So there's great value in having this for all the languages. OK, data model, that historically used to be a big problem. So metrics, different ideas how metrics look like, different ideas how logging looks like. But once we have a rich data model, you can always break it down to simpler models. And I think this is not that hard anymore. This is one of these simpler problems. Metrics are labels, logs are structured. Tracing is the most complicated of the 3. And for better or worse, I think open tracing is pretty much what people do, even if they don't necessarily like it. OK, this is the hard part, and I think this would be many, many other talks. Push versus pull, like how the collection works. Is it an on-prem system? Is it some cloud provider where you just shovel over your metrics and logs? Is it distributed versus replicated? It's a bit subtle. Prometheus is not a distributed system, but it's a replicated system, and that's for a reason, because it's robust and simple and works on-prem. So could nerd out about this a lot. Where do you sample? Where do you aggregate? Where do you buffer? What exposition formats are using which transfer protocols, gRPC, HTTP, whatever. There's a lot of stuff in there. One might argue this is all not a concern of instrumentation. But instrumentation kind of needs to abstract this away. And there are instrumentation libraries that have baked in that you need to send an UDP packet to the stats server, for example. So you want to make this a bit universal. Prometheus instrumentation libraries try this a bit. They're like bridges, so you could also send stuff to Graphite. But this is where you can already see that the instrumentation library needs to think about this, even if ideally, if you use it as a programmer, you don't have to worry. But that's the hard part. OK, now my secret hope was, when I submitted this talk, at the time I'm giving the talk, a project called OpenTelemetry will have stayed faithful to their roadmap and will have released a lot of awesome stuff. And I could just endorse this project, because this is kind of trying to fulfill the premise. If you look at the web page, it goes about, this is about metrics and traces and logging, although if you read further, they say OpenTelemetry will not initially support logging, though we aim to incorporate this over time. OK, fair enough. It aspires to do it in all the languages. They have JavaScript, Python, Ruby, C#, Go, Java, checks everything except C and C++ from the list. They even have a plan for PHP. They are like part of the CNCF, so they definitely try to be in this space of being the canonical cloud-native solution, and also playing nice with all the other projects, which kind of fulfills the data model part. So it all looks kind of very interesting, but then the roadmaps are just roadmaps, right? So it's a lot of it is still in flux. It's not quite there yet. So we have to watch and see. We have to wait and see and watch, whatever the expression is. Johannes already mentioned OpenTelemetry in his tracing talk yesterday, mostly the tracing part, and arguably the library and the implementation they provide is mostly about tracing. The idea of this is really great. There was open tracing and open sensors. Open tracing, just like an API definition for tracing to get us all on the same page. Open sensors was tracing API and implementation and also instrumentation for metrics. And they were both in the CNCF and kind of working not really together. And then they just said, OK, let's make the next version of open tracing and the next version of open sensing be the same. I'm not yet sure if this will really work out well, but the idea is awesome. And this will kind of, if that works out, and I mean, they're working really hard on it, it will essentially make them the winners, for better or worse, right? The vendors are behind it, especially the tracing vendors. Now, I had a lot of chats at the conference. Somebody said this was just cooked up by vendors, and they have never asked the users, but it's also used a lot. What I really find interesting, and this is kind of the only case where I really see this, that they have thought a lot about this collection part, where I said this is really hard. And this is because you can just use, I mean, it's still, you see, it's still open sensors, but it's supposed to now be, they haven't replaced this with OpenTelemetry, but it should all converge. So they have this idea that you can just totally bake it into your binary and do the Prometheus-style collection, where the Prometheus server scrapes it from your binary. Then you can have a separate agent here. You can have it in a sidecar on Kubernetes. You can have a daemon set on Kubernetes. This all works. There's an open sensors collector, which will then be called the OpenTelemetry collector, I guess, which can combine this. Then you can, again, let Prometheus scrape this, or send stuff to Jaeger and Zipkin, or you can send it all to Datadog, or Stackdriver, or whatever vendor you choose. So this, I think, again, this is a great idea. We have talks mostly about tracing, because that's the complicated part. This was about open tracing proper, but they already said there's OpenTelemetry, and it should just more or less seamlessly work. And then Johannes had this talk explicitly about OpenTelemetry, but just about the tracing part. Now, the metrics part is ongoing. Do I have this? No. The metrics part is ongoing, but this kind of idea of unifying it all, that you have this one line, instrument this HTTP call, and it will just magically have metrics traces and logs. It's not quite there yet, although it was demoed for open tracing that this is possible. So we have to see. Also, I mean, I've worked for years on this Prometheus instrumentation library. I have strong ideas how this should work. It's very mature. And in the talk by Bartek and Kemal, you could have seen how much thoughts went into the library. And from that perspective, what they do in OpenTelemetry for metrics is a bit, yeah, not yet so mature, but yeah, we have to give them a chance, right? OK, but now what? Like, it's not quite there. How do I instrument code in 2020? So 3 steps as the conclusion of this talk. 3 steps to peace of mind. I mean, this might give you trouble to accept that OpenTelemetry will be the winner, but I can't really see. I asked around. Many people I asked are not happy. Some are really happy, and that's usually the case. But there is no viable alternative to do tracing in some kind of standardized, generic way. Open tracing is kind of where it is, and OpenTelemetry will be the successor. And so I think it's kind of safe to bet on OpenTelemetry as the winner for tracing. Once you have accepted that and come to peace with it, you can relax. Because logs and metrics, they are actually the way simpler parts of it. And there is a lot still going on, but those instrumentations are often just a line. It's a line to log something. It's a line to set up, to increment a count in the metric. So this is all not that problematic, even if we don't have the super unified view on everything right now. Also, you should always remember that tracing is not everything. It's a very hot topic now. but sometimes you just have to log something, and this is not connected to any request you want to trace. Sometimes you just have a metric that is an interesting metric to learn something about the inner states of your system, and it's not a trace. So this will always happen. You always will need this, and if it's all in a unified library at some point, great, but you might just be happy with your GoKit logging and Prometheus instrumentation client for now. And then, this is, I mean, general advice in any practical programming. Take your context into account. If you already have something in your organization and it just works, you should not just say, OK, now we have to do all open telemetry and kick this all out of the window. Also, I mean, this has a good part. Many of us will not write instrumentation libraries, for example. We just write a microservice. And then we might use something like GoKit or some Kit library framework provided by your organization, finagle in the JVM world or something. Or we even run hipster alert or buzzword alert. We run the service mesh. And they have baked in telemetry. So this is also one of their selling points. You do it with the service mesh, gives you metrics. Tracing is, again, complicated because of context propagation, but the idea is that it's fairly easy. And logging is there, and you get a lot for free. And at SoundCloud, we have this JVM kit, which is kind of on top of finagle. And in the SRE, Seeking SRE book, we described how we kind of run our production systems. And one of the sentences is, we made it harder to not have instrumentation than having instrumentation. Because it's just so baked in, you have to intentionally avoid it to not have it. And if you're in that situation, you just use what your context provides you, and then perhaps on top you have a few custom things. And later they might, under the hood, change it all over to OpenTelemetry or something. So perhaps you are not that concerned anyway. So this is the kind of hopeful message I can give you. Unfortunately, not yet the endorsement how we all should do it in 2020. Thank you. So perhaps we have 90 seconds for questions or something. I'm also around. You can ask me things later, but now's your chance. OK? Even better than we don't have to go over time. OK? See you later. Thank you.